Hello students, how are you doing today? This is Mr. Elliott. I hope you had yourselves a wonderful weekend. Let's go ahead and get into today's lesson, shall we? You're going to need some graph paper today, so if you don't have graph paper, stop, pause, go get some graph paper, come on back, hit start again, let's get going. Let's make Elliott smaller. Ooh, hey, check it out. It's Elliott's leftover pizza. And underneath his leftover pizza is today's lesson. It is called Solving Systems of Equations. And this is actually pretty much part one of a four-part lesson. We're going to spend 3 days talking about the different techniques of solving systems of equations. Today, graphing. Tomorrow, substitution. On Wednesday, elimination. And then on Thursday, we'll do it with story problems. And that's systems of equations. What is a system of equations? Well, a system of equations is when you are given more than one equation and you're looking for the solution of it. We'll talk about that, what that means in a couple minutes when we get to the graphing. First thing I'd like to talk about is advantages, disadvantages. Advantages, disadvantages. Wait, I'm spelling this wrong. Vantage is. I feel that there's two advantages to graphing, solving systems of equations using graphing. The first advantage is that it's faster, at least for some people. If you're a really bad grapher, maybe it's not going to be faster for you. But if you're a good grapher, graphing can be really fast if you're given a good equation to use. Second technique is I'm one of those people that believes that a picture is worth 1,000 words. It puts a 1,000 words. It puts a great visual on the problem and makes it pretty easy to understand where the solution of that problem is. So if you struggle with algebra, a nice graphing solution usually helps people understand what it is we're trying to do with systems of equations. The biggest disadvantage is that because you are looking at a graph with doesn't give you the decimals, solving a system using graphing can be very inaccurate. Depending on your quality of graphs, especially if you're not using graph paper, if you're not using a straight edge, it can be really inaccurate really fast. So if you're trying to get a really accurate answer, graphing might not be the best technique for you. So let's go ahead and get out some graph paper and oh wait. Before graph paper, we have to talk about part two, which is the 3 types of solutions. So there's 3 different types of solutions that you could get. The first type is like the normal problem. This is what you expect to have happen in a problem. You're going to graph one line, you're going to graph another line, and you're asked, where's the solution? Well, if you ever heard the term X marks the spot, that would definitely suffice here. Where the 2 lines intersect is the answer. And 2 lines on an XY plane on a flat surface will always intersect in just one spot. So in this particular case, there's one solution because the 2 lines intersected in just one spot. Second situation, well, what happens if the lines are parallel? I have line A here, line B here, and it tells us that A is parallel to B. Remember your geometry, everybody? Parallel. All right, well, if they're parallel, when will they intersect? Definition of parallel, never intersecting lines. Well, if they never intersect, there would be no solution. Now, the third situation is if they don't intersect once and they're not parallel. The third situation is when the 2 lines are actually the exact same line. So when you graph the two lines together, they completely overlap. Well, how many times does the exact same line overlap? How many times do they intersect? Well, every single point along this line, every single point, are all considered solution points. So that means that there are an infinite number of answers. Now, this isn't the very best answer to give in this situation, but at this level of math, this is as accurate as an answer as I need for you to give. If you're interested in getting a more accurate answer, talk to me tomorrow in class. I'd be happy to share that with you, but that's really advanced and kind of beyond the scope of this problem. At this point, all you need to know is that if you graph the two lines and they are the same line, that means that they intersect an infinite number of times, so there are an infinite number of answers or solutions. Okay, so those are the three types of solutions that you could possibly run into. Let's go ahead and get into some examples. Solving systems of equations, graphing. And I have two examples for you. And in these two examples, I am going to show you three techniques on how to solve them. And you'll see what I mean when we get there. Example one, I'm just going to show you one technique. For number two, I'm going to show you two different techniques. So my equation for number one, or my equations, the equation my first line is y equals 2x minus 4 and y equals negative x plus 5. And to do this problem nicely, you're going to need your graph paper and a straight edge. First, make your x and y axes. I've dropped my straight edge. Excuse me, everybody. There we go. All right, so we make our x and y axis first. X-axis, y-axis. And when our graph is in slope-intercept form like this, it's nice and easy to graph. We start with our y-intercept here of negative 4, negative 1, negative 2, negative 3, a y-intercept of negative 4. This is a slope of 2. Slope, as we've talked about, is called rise over run. A lot of people like to take that 2 and make it a fraction, 2 over 1. That is telling you to go up 2 to the right 1, up 2 to the right 1. You go up or down depending if the slope is positive or negative, but you always travel to the right. So there's my first line. And then my second equation, y equals negative x plus 5. Start at the y-intercept, 1, 2, 3, 4, 5. Hey, there's no number in front of that x. Well, negative x is equal to negative 1x, written as a fraction, is negative 1 over 1x. So when you see negative x, you want to be thinking negative 1 over 1x. So from here, down 1 to the right 1. Down because it's negative, then you always travel to the right. The more dots you put into your graph, the more accurate your graph will be. So if you struggle with cleanliness when it comes to your graphs and making nice, pretty graphs, it's a great idea to do is use a ton of dots. And as I talked a little bit ago, where these two lines intersect will be your solution. These two lines intersected at the point 3, 2. So you write your answer right there. It's a coordinate. Your answer is a coordinate, so put it in these parenthesis bracket things. And when you're drawing lines, because lines go on infinitely, please put arrows on them. Lines that don't have arrows technically aren't lines, they're segments. So that's example one. Graphing a couple lines when they're both already in y equals. Now, for example number 2, I want to show you two different techniques to solve this one. And because it's let me write down the equations first, and you'll see why this one's different. Our first equation is 2x plus 3y equals 12, and the second equation is x minus y equals 6. These equations are in standard form, and means that there's a little bit more work involved. I'm going to show you my two techniques. Technique one. Technique one is using x-intercepts and y-intercepts. X-intercepts. When the y-coordinate is 0, what is the x? The y-intercept. When the x is the 0, what is the y? So you need to do this with both equations. So you first start off with 2x plus 3y equals 12. I plug in 0 for the y. 3 times y is just 0. This becomes 2x equals 12. Divide both sides by 2 and x equals 6. So the x-intercept is 6. The y-intercept, the exact opposite. You plug in 0 for the x, which means the x will essentially go away. 0 plus 3y equals 12. 3y equals 12. Divide both sides by 3. Y ends up being 4. You do the same thing for the second equation. When I plug in 0 for x, I forgot this is a 6. When I plug in the 0 for x, that's going to leave me negative y equals 6. If I divide by negative 1, I'll get a negative 6 here. And if I plug in 0 for the y, put your finger over the y because that would go away, you're left with x equals 6. So you're essentially finding the x-intercept and the y-intercept for both problems. And this makes graphing very, very fast because you just have 2 points you need to connect the dots to. So my first equation, I had the points 6, 0, 1, 2, 3, 4, 5, 6, and the point 0, 4. Connect the dots. Don't forget to put arrows on your answer, on your graph, excuse me. Then the second line, I had 0, negative 6, 1, 2, 3, 4, 5, 6, and 6, 0, 3, 4, oh, that's right here. Connect the dots. Now, whereas I really like this technique because it's really fast, because you're only having 2 dots in each direction, it does lack accuracy. So make sure that you're showing all of your work so that if your answer does have accuracy issues, I can still get you full credit, or at least most of your full credit, depending on the problem. These two graphs intersected at the point 6, 0, so that's my answer. That's technique 1, finding x-intercepts and y-intercepts. My second technique I'm going to use for this problem is called is getting them into slope-intercept form. So I'm going to take both of my equations and I'm algebraically going to solve them for y. So I take 2x plus 3y equals 12. Subtract the 2x from both sides. So I get 3y equals negative 2x plus 12. Divide everything in the equation by 3, and y ends up equaling negative 2/3 x plus 4. Do that with the second equation. Subtract x from both sides, and I'd get negative x plus 6. Divide both sides by negative 1, and this becomes positive x minus 6. And then, just to save time, I'm actually just going to go down to my other graph and demonstrate that it is the same type graph. X minus 6, this one, I would start at the y-intercept of negative 6, go up 1 over 1, up 1 over 1, up 1 over 1, connect all the dots. On the second equation, y equals negative 2 over 3x plus 4, start at that y-intercept of positive 4, down 2 to the right 3, down 2 to the right 3. Connect the dots, and hey, I got the exact same graph. They intersected at the exact same spot. Okay, so that was 2 examples, 3 techniques of the same problem. Hey, thanks for asking about my weekend, everybody. As you recall from last Friday, I did a triathlon this weekend. I did the Black Diamond Triathlon, and if you were in class today and you saw my shirt, it's the shirt that I got at the race. Now, one thing that's cool about every triathlon that you ever do is they always give you a finisher medal. Here's my triathlon finisher medal. It's got a nice mirror on the back side so that you can make sure I look nice and pretty all the time. That's what my camera looks like. Hey, Elliot. And then this particular race, my third race of the year this year, and I actually won my age group. And here's my pint glass that I won with my age group. This is my my award. I got 12th place overall. I was 7th place after the swim. I held on to my own, and I was still 7th place after the bike. And then my weakness was running, and I ran as fast as I could. But I guess 5 or 6 people passed me, and I ended up in 11th or 12th place overall. But the big reward was winning my age group. That was pretty cool. So that was my triathlon this weekend. If you feel good about your practice at this time, I think you're good for your lesson, and you should move on with your life. But if you'd like a little bit more practice, I have 2 more example problems for you. Here's example number 3. These are the 2 equations. The first equation, y equals 4x minus 10, and the second equation is y equals 1 over 3x plus 1. Okay, pause this video while you try this problem on your own, and in 5 seconds of my reality, I'll present my answer. 1, 2, 3, 4, 5. Elliot's answer. I graphed the 2 lines, and I end up getting a solution of 3, 2. If you have more questions about this problem, it'd be a great idea to ask me about it at questions at the beginning of class. The other problem, a second example problem you could try out. The first equation is hold on, here we go, negative 2x plus 3y equals negative 9. And the second equation is x plus y equals 2. And I solved this problem using both Technique 1 and Technique 2. Same thing, if you are doing this problem, pause it for a minute, try out this problem on your own, and then hit play and check out your answer. 1, 2, 3, 4, 5. Okay, the work that you see up on the screen, if you use Technique 1, I got intercepts of 0, -3, and 4.50 for one graph, and 0, 2, and 2, 0 for the other one. And got solution of 3, -1. For the other technique, I solved the 2 equations for y, and one equation was y equals 2 over 3x minus 3. The other one was negative x plus 2. And when I graphed the 2 equations, they intersected at the same spot. Don't forget to write in what the correct answer is. Elliot forgot there. And that is 2 more examples. And at that point, if you're feeling good with systems of equations using substitution, you're in a good spot. Tomorrow I'll have some practice problems for you, and I hope you have yourself a great Monday night. Oh, let's make Elliot bigger for the bye-bye. Bye-bye, everybody. Have a great night.